right, we're just going to do a quick kind of once over for chapter 3, section 1 through 3 review. So to hit the big ideas that we talked about in the first part of the chapter about linear graphing and equations and slope and all those good things. So we're just going to walk through some highlights. I'm not going to do the questions, give you the chance to try those, and you can come back and take a look and see how you did. So make sure you know what quadrants there are and where they are. So thinking about how we number them and what you know about the signs in each one. So starting in quadrant 1 in the upper right, and then going counterclockwise around. So make sure you know about that. Being able to, for number 4, just using a linear relationship. So being able to solve. So hopefully that should be okay. First real formula you need, let's take a look at number 5, midpoint formula. Remember, it's the middle. See if you can look back in your notes and find that formula and look through the examples that you are given. Go back through your notes and do all that highlighting too, so you find all those places where there are kind of important things for you to remember. But the midpoint formula, remember where the middle of 2 points are, the word that we used was average. So adding the x's, dividing by 2, adding the y's and dividing by 2. So remember, midpoint is an ordered pair. It's a location. And remember, you can always make a graph, make a little sketch to see if it seems like a reasonable value. Completing a table, that's just using substitution. You have your input or your domain value, and you're trying to find the range value. So that should hopefully be pretty straightforward. Graphing, finding the intercepts. Let's talk about x and y intercepts again. Intercepts, remember, are where the graph crosses the x or y axis. A nice way to think about that is the way I kind of do it with the table. Finding the x-intercept is where it crosses the x-axis. That means the y value would be 0, and if you're finding the y-intercept, it's where the x is 0. So for me, I like to think of it as this table. Some people think, okay, I'm going to let y equal 0 and solve for x, and then you're going to let x equal 0 and solve for y. Same thing. Those are called the intercepts. When your equation is in standard form, it's a really nice way to do that. So they're asking you for intercepts for a couple of these. Remember your special cases too. X equals a number and y equals a number. Remember what kind of equations those are. X equals a number. We talk about all the x values are the same. That's a vertical line. Do you remember what kind of slope a vertical line has? If it's vertical, what kind of slope do we call that? Well, the slope, undefined. The rise over run, that run number on the bottom would be 0. There's no value. You can't divide by 0. If you have y equals a number, do you remember what kind of a line that would be? Just y equals a number, like y equals 7. Well, that's horizontal. And do you remember what the slope is for that? A horizontal line? That means rise over run, the rise is 0. You're not going up or down, so that means the slope is 0. Some of those special case linear equations are supposed to be easier, but gosh, they're harder for people a lot, so just be careful on those. So graphing with intercepts and being able to recognize vertical and horizontal lines. Also, you can, remember, you can just get into slope-intercept form to be able to graph, and that's another option that you have if you don't want to find intercepts, or maybe the numbers are gross if you try to do that simplifying or that solving. So slope-intercept form is a great way to do that. Go ahead, pause the video quick, see if you remember what slope-intercept is. Write it out. All right, y equals mx plus b. And remember what each of these values are. What's the m and what's the b? What does the m represent? Well, that's your slope, your rise over run. The b is the y-intercept. It's a great way to be able to sketch. So graph your y-intercept first and then use your slope to get to another point. So basically what that involves then is just for most of these equations, how would you get it into this form? Well, you would just solve for y. So being able to get into slope-intercept is another way of graphing. All right, slope formula. How do you find the slope if you know 2 points, 2 ordered pairs? Slope formula, m equals. So we talk about rise over run. So what does rise mean? Well, that's the vertical change. So vertical change means you subtract your y values. And run, that's the horizontal change. You subtract your x values. So rise over run. Just be really careful on your arithmetic. That's where people come into issues on this. And be careful with how you simplify your fraction. All right, parallel, perpendicular, or neither. So 2 lines can either be parallel, meaning they don't cross at all, or perpendicular, where they cross at what angle? 90 degrees. Or they could be neither. They could just cross in some other fashion. So what do you know about 2 lines that are parallel? Well, they have the same rate of change or slope, so their slopes are equal. Perpendicular. What do you know about perpendicular? Easy for me to say. Slopes. They are opposite reciprocal. So slopes are opposite reciprocals. All right, so opposite reciprocal. So being able to figure out if something is parallel, perpendicular, or neither, you have to look at their slopes. So we want to find their slopes. So sometimes that means if you have an equation, you want to get it into that slope-intercept form, make it a little bit easier to deal with. So if you have two equations that you can't really tell, in order to find the slopes, you want to put it into y equals mx plus b form, and then you can see what that slope number is. So solve for y. If they give you two ordered pairs, how would you find the slope? Well, we have a slope formula, right? So we could be able to use that slope formula here, and then you're going to compare the slopes and see what you know. All right, for the last part, we talked about writing equations. So being able to write equations often, it just depends on what you're given, but most of the time you have a point and a slope. So we use what we call point slope form to be able to solve. So point slope form is a really nice one for writing equations. Where often we like slope intercept for graphing, point slope form is great for writing equations. Y minus y1, mx minus x1, where x1, y1 is your point, your ordered pair. That's the point that you know. And then m is your slope, obviously. So we can write that equation, and then that's an equation of the line. Then we can put it into any form that we want. So if you want it in slope-intercept form, you can just solve for y or whatever. So it's a nice form for writing equations. And all the way down this end, that's what we're doing. So looking at horizontal and vertical again, so remember what the forms those are in. And for the last one, you want to write something that is parallel or perpendicular to another line. Write an equation. Again, point slope to start is really handy. So starting with point slope and then just solving for y to get it into slope intercept form, then you can transform it into that form. So it's a nice way to start. But you have to be able to get the slope. You need a slope and a point. So if it's parallel to something, probably the easiest way to deal with that is get it into this slope intercept form. So solve for y. So you can get that into the right form to be able to tell what the slope is, and then you can use that slope number and the point to write the equation. So all of kind of the big ticket items here for being able to work with linear equations. So we need to understand slope intercept, point slope. We need to know the slope formula, the midpoint formula, vertical and horizontal lines, and then being able to figure out where plotting points and putting the values in. So that's the big picture on the review. Give it a try, and then we'll see what questions you have.